writing. Alright, we're going to work through gravitational time dilation, number 3 and 4. That one. I'll start reading these. The mass of Sagittarius A star, it's the black hole at the center of the galaxy, our galaxy, just so we're sure, has a solar mass of 4.3 times 10 to the 6th. That's 4.3 times 10 to the 6th times our sun's mass. When objects get too big, we just start calling them solar masses. Without we have a known thing, and then we don't have to keep adding a ton of zeros. It just makes things a little easier. It's a unit of measurement. Okay, so one solar mass is the mass of the sun. We just said that. I just said that. Not we. Maybe you did too. I didn't hear. And it has a radius of 2.2 times 10 to the 10th meters. So we're going to teleport to the surface of the black hole. We're going to assume it's the event horizon, what we could see. And you're going to live there for 1 Earth year. Then you teleport back to Earth after that year on the black hole. So assuming you left Earth this year, what year is it when you get back? We're going to figure out how many years you were there. And you can math from there. Okay. So I've got my equation here, which we had to fix because there was a problem with the... Can you see that? I think you can. We have t equals t prime. Then we have the square root of 1 minus 2gm over rc squared. Our t and t prime were backwards originally. We caught that and switched it because I looked it up and they had it labeled differently and fixed it. Well, now I question everything. Okay. So I'm going to start plugging in the things we know into our equation. T prime is time measured outside the frame of reference. Because we're on the black hole, our time would be the black hole time. Outside our frame of reference is going to be the Earth time. That's our 1 year. Because that's going to pass, but we didn't see that 1 year. We're going to see just t. We're going to solve that t. So we have 1 minus 2. This is 6.67 times 10 to the negative 11th, right? M. The mass of Sagittarius A star, that was given to us as 4.3 times 10 to the 6 solar masses. Since one solar mass is the mass of our sun, we have to multiply the 4.3 times the mass of the sun. I hope this is big enough that you can see. I'm guessing, hoping. So we're going to multiply by the mass of the sun, which is on our chart here. So it's 1. I'm going to write bigger. 1.99 times 10 to the 30th. There we go. Alright, so now we're going to divide by the radius in c squared. So radius is, it's on our problem, it's 2.2 times 10 to the 10th meters times 3 times 10 to the 8th squared. Okay. Deciding how to best do this. If you want to see my buttoning, pushing the buttons, or just simplifying there so you can check along. How about we simplify here as we go? Okay. I'm going to start by simplifying this top part down. I'm going to start with 6.67 to the negative 11th times 2. So I've got this. That gives me 1.33 times 10 to the negative 10th. But I'm going to multiply it by our solar masses. So I'm going to put in parentheses and multiply by, I guess it doesn't matter, right? My solar mass, I'm going to simplify here. I think I've said that like 6 times now. Times 1.99 to the 30th. Alright. So the top now simplifies down to 1.1415 times 10 to the 27th. Now, to the 8th, and that's squared. Because there's a bunch of numbers stored on my calculator that I can't even see, I'm going to keep going on my calculator here without showing this bottom part simplified. I'm going to hit divide, open 2 parentheses, and then put in my 2.2 inside my 2 parentheses to the 10th. I'm going to close the parentheses and hit times, open another parentheses, 3 to the 8th squared. I don't know if you can see, that's what I put. That's what I put. I don't know. But I'm gonna simplify this whole thing now, which comes down to square root of 1 minus 0.5765. And this is still 1 year out here. 1 year. Kind of getting lazy on those. Okay, so now I'm going to take 1 minus, shift the negative, negative button. So this simplifies down to 1 year, square root of 0.423. So I'll get the square root next. Square, shift answer. So we get t equals 1 year. This can't be right. This has to be backwards. Times 0.65. This has to be backwards on our times. Because that would mean that we spent a year on the black hole and only half a year passed. These have to be switched. It's the only way this works. So this actually needs to swap places. I'm just using logic on this, so we should end up with 1 divided by our decimal thing here to get our time actually equaling 1.537 years. I really don't like these ones. We can use our logic to think these ones through, right? Remember back to Interstellar where they went close to the black hole and it's like, this is going to cost us 80 years, or they say 80, I don't remember. A lot of years. And so being near on a black hole should change your time, so outside should be a lot more. So we should get a bigger years outside, not inside. Or less, smaller number. Because these need to switch places, so our year needs to be out here, and t needs to be in here. And we can logic that one. Oh. Which means our t prime was in the right spot, and then we switch it. These frustrate me now. We may not do these ones on a test, and we may stick to just the speed ones. Which means we watched Interstellar for nothing. Sad. Okay. Save time, because I got other stuff to do. I'm going to go to the next one, and we can debate this back when we see each other again. But we know that's what the answer should be, is a longer time on the, short time on the black hole, long time outside. Alright. Am I labeling my T's wrong? Well, you live there for 1 year, and that's your in... Sorry. I did. I labeled my T's wrong. That was my fault. That was dumb of me. Because it should have been out here to begin with, because T is inside your frame of reference. You live there for 1 Earth year, so it is end up right. I was just dumb and put these wrong the way I read it. So this does belong out here because we don't have T prime outside your, right, because you were sitting on the black hole waiting, like, for you as 1 calendar year, and you were measuring from there. Okay. We can talk about it more later, but that was backwards from the way I read it. We'll read this one right. Number 5. The largest known black hole is TON, ton 618. I googled this. At the time, it was the biggest. I don't know if it is anymore. You Google it and you get back to me. Or tell Maddie about it. It has a mass of 6.6 times 10 to the 10th solar masses. And you win an all-expense paid vacation for a full year on the surface of ton 618. So you're teleported there. Teleportation exists in this made-up universe of ours. So you're teleported there for 1 year, and you return to Earth to find that 866.47 years have passed on Earth. What a good trip. What is the radius of ton 618? And why would you agree to this vacation? Everyone you know is dead now. It's been 600 or 800 years. Why? Don't do this trip. Yeah. Okay. So we're going to solve for radius. I'm going to solve this algebraically first. I don't want to do all the math at once. So I'm going to solve this with algebra first. T prime square root 1 minus 2g m over r c squared. I'm going to solve algebra first because it's, they don't have to write as many numbers. I can just manipulate this around. So I'm going to first divide by t prime. So I get t divided by t prime equals square root of 1 minus 2g m r c squared. I have to get rid of the square root next before I can do anything. So I'm going to square both sides. So I get t over t prime squared equals 1 minus 2 g m r c squared. This is terrible. I have to subtract 1 over to the other side, and I'm also going to have to divide by negative 1. I'm going to do both at the same time. So I get t over t prime squared minus 1, but I have to flip my signs on everything because I was at divide by 1, because I would have had a negative there. So I get 2gm rc squared. But I need r by itself. Cool. So I'm going to multiply by Gross. I'm just planning how I want to do this ahead, because I didn't plan it ahead. Or I get r over there, but I'm still going to end up with it in a denominator no matter what. So I'm going to do c squared, multiply both sides by c squared, so those go away. And then I get negative t over t prime squared times c squared plus c squared. Oh, we saw that before. Equals 2gm over r. I'm going to end up flipping all these later. Gross. I don't like this at all. I'm going to divide by the 2gm on both sides. So I get 1 over r on that side. And this is all going to be divided by that 2gm. So we have t over t prime squared c squared plus c squared over 2gm. Gross. Yeah. Can we leave it at that and then take the inverse later? Otherwise we got to flip all the less writing, right? Okay. So enough room for me to write over here? I think so. Okay. I'm going to leave it right as that right now. And then at the end we'll fix our r. Because right now we have 1 divided by r. So we'll do that at the end. With math. Okay. So now we have to figure out r. Our numbers. So t and t prime. T prime is measured outside our frame of reference, and that is going to be the 886 years. Right? So t is 1 year, so we have 1 over 866.47. Let me double check this to make sure I'm right. You win Knoxville. So you spend a full year on that. So you've got the calendar and your time and you're watching that go by. Because what else are you going to do on a black hole? You don't go in it, you're on the surface, right? So no Matthew McConaughey stuff where you get to go mess with somebody and be their ghost. So T is inside frame, so that's 1 year, and outside, yeah, I'm going to go with this. And this is a negative number, and we're squaring it, so I don't think that negative, well, negative is going to stay out there, right, because we're multiplying by it. And we know c squared doesn't change, because that's the speed of light, plus c squared, square root. I'm going to leave it at that. Over 2, I'm going to leave big G. We know the mass of it is 6.6 times 10 to the 6 times the solar mass, 1.99 times 10 to the 30th is our solar mass. Big G is a constant, right? That's 6.67 times 10 to the negative 11th. That's why I didn't write it, I just left it as a G, which looks like a 6. That's a little more GE. Yeah, GE. And this is all inverse of the radius. Or, yeah. Calculator time. So I'm going to start with this top stuff and start simplifying here. So I'm going to take 1 divided by 8.66 for, no, I screwed that up already. 1 divided by 866.47 gives me 0.00115. But I'm going to square that. twice. Ah, I screwed it up. I went too far. Hang on. 1 divided by 866.47. Now squared. Hit the enters twice. So now I have like 5 zeros and then 1 3. Now I'm going to multiply that by c squared. So I'm going to open the parentheses, put c squared, so 3 to the 8th squared. Close my parentheses. This is going to equal, I need my marker again. I'm going to write this down now. So 1.198. And it's a lot longer. 8, 7 times 10 to the 11th. Well, that's plus c. C squared over 2g. Then we still have this 6.6 times 10 to the 6th. Which is 1.99 times 10 to the 30th. We still have all that to go. So I'm going to add the speed of light to this number. Uh-oh. I made a mistake. So negative answer plus whatever 3e to the 8th squared is. I hope I did this right. That doesn't seem right. Crud. I think I screwed up here. I'm going to have to rework this. Ready? So we're going to do this again. 1 divided by 866.447 squared times 3 to the 8th squared. Oh, we need to make sure I'm putting it in parentheses. Okay. Now I can add 3e to the 8th squared. I got the same number. I don't know. So 8.99998 times 10 to the 16th on the top. And now 2g times 6.6 times 10 to the 6th times 1.99 times 10 to the 30th. Oh, I'm going to do all this part at once. Maybe. That's gross. Maybe I won't. And I'll put the extra 8 there. Because I don't like doing it all at once. We'll see how it works out. It's multiplying, so I should be able to multiply every number. So I go 2 times 6.67, shift e to the negative 11th, times 6.6 to the 10th, nope, to the 6th, times 1.99 e to the 30th, so this simplifies down to 5.1367 times 10 to the negative 11th. It's 1 over r. So I should be able to take 1, divide by my answer, right? And it gets me a radius. All I'm doing is switching the r in this number places. So I have 1 divided by this number, giving me a radius of 1.947 times 10 to the 10th meters. And when I looked it up, that I believe was the answer that I got when I looked it up. I'm going to double check. Pull out my computer really fast, so don't go anywhere, but I'm going to double check the radius of uh-oh. that should work. Getting a different number. What is that? Because times 10 to the... I gotta check this because I'm struggling with the brain thing right now. Yeah, I got a different number than what is given online. Cool. Because online it says times 10 to the 17th. But that's the right number here. Times 10 to the 17th. We're pretty close. So I'm going to go with this. Because these are the numbers we were given. And I don't remember when I made this, what I made up. It might be a little different. I might have guessed on a radius or a mass. Might be slightly off from what it was. I'm going to look up the mass. 66 billion. Yeah. This is our problem. That's why we have a different number. Great. I have the wrong one in there. But that's okay, because that means this is okay. And we did it. I'm going to post this online. We can talk about this too later.